Okay, so in this lesson, we're going to go further with factoring. In the first lesson, we factored polynomials that had a greatest common factor, a GCF. So for example, we were factoring things like 4x squared minus 8x. The GCF was 4x. They each have a 4 in common and they have one x in common. Okay, so this would factor as, let me do this over on the other side. This would factor as 4x times, and then remember we're rebuilding the polynomial, so 4x times x makes x squared, makes 4x squared, and then 4x times negative 2 makes negative 8x. Okay, so in the factoring problems that we're going to look at now, we don't have a GCF, okay? And most, if not all of the time when we looked at in the first lesson, we were looking at binomials, 2 terms, okay? Here we're going to concentrate on trinomials, 3 terms, okay? So what we want to do is factor things of the form ax squared plus bx plus c. So something x squared plus something x plus some constant, trinomials, all right? And if you look at the first example, x squared plus 4x plus 3, those terms don't have anything in common. If you try making a factor tree for x squared, 4x, and 3, you're going to see that they have nothing in common, all right? So what we want to do, we want to start by creating a list of factors for c. c here would be the 3, all right? The only way to make 3 and 1, right? There's no other way to make 3. 3 is a prime. Okay, we want to look for a pair of factors that add or subtract to b. b here would be the 4, all right? And of course, 3 plus 1 makes 4. So the factors of this, we're going to open up 2 sets of parentheses, okay? Since we positive 3 and positive 1 multiply to positive 3 and they also add to positive 4, we're going to put those over there, okay? Now we have to look at the first term. How do you make x squared? Well, x times x, right? So our factors are going to be x plus 3 times x plus 1, all right? So now, well, let's just write. Now we can check our answer. The way we check to see if it's factored correctly, multiply out, okay? So this is a review of multiplying 2 binomials. We distribute the x times x is x squared, x times positive 1 plus x, 3 times x plus 3x, and 3 times 1, positive 3, okay? And then the middle terms are combinable, so x squared plus 4x plus 3, all right? Which is what we started with, which means that we have the correct factorization. All right, so let's look at number 2. Y squared plus 9y plus 20. We're going to make a factor tree for 20. 20, 5, and 4. Okay. And we don't want to break it down to primes. We just want to keep looking at possible whole numbers that multiply out to 20. So I can also do 10 times 2, right? That's the only way to make 20. So we need to look for the pair that add or subtract to b or add or subtract to 9. And of course, that's going to be the 5 and the 4. Okay, so we have a y squared in front. let's first put these are both going to be positive because positive 20, positive 9. Okay. And the way we make y squared is with y times y, all right? And if we multiply back out, y squared plus 4y plus 5y plus 20. And that's our 9y, okay? So we do have the correct factors. Okay, number 3, slightly different because not everything is positive. We have that negative middle term. Okay, so we can make 16 by either 8 times 2, okay? And we should also do 16 times 1, and then we can do 4 times 4. Okay. So the pair that either adds or subtracts to 8 is going to be the 4 and 4, all right? So we have the leading coefficient, we have an x squared, so we need an x in front. Now, how do we make them combine to negative 8 and multiply to positive 16? What do the signs have to be? Well, in order to get them to add to negative 8, they both have to be negative because negative 4 and negative 4 combine to negative 8. And then negative 4 times negative 4 gives us that positive 16 in the end. Okay, so this is going to be x minus 4 times x minus 4. All right. So if we check, this is going to be x squared minus 4x minus 4x plus 16. And there's our negative 8x, okay? And let me do some erasing. This is getting pretty crowded. Okay. By the way, when we have x minus 4 times x minus 4, another way to write this is x minus 4 squared, okay? Okay, so next one, x squared plus 6x minus 16. We'll make a factor tree for 16. We already had it for the other one, but we got 16 times 1, 8 times 2, 4 times 4. So the pair that either adds or subtracts to 6 is going to be the 8 and the 2. Okay. So now we have to play around with the signs a little bit. Leading coefficient, x squared. So I need an x and an x in the front. Now, what do I have to do to 8 and 2 to make them add to positive 6? So let's write this 8 times 2. Add to positive 6 and multiply negative 16. Okay, so if they're going to multiply a negative 16, one of them has to be positive, one of them has to be negative, all right? So the way that we're going to get them to also add to positive 6 is we're going to do positive 8 and negative 2, all right? Because positive 8 and negative 2 adds to positive 6, and it also multiplies to negative 16. So it's going to be x plus 8 times x minus 2. All right, and I'll leave you to do the check for yourself. You should see when you multiply those two binomials out, you will get what we started with in number 4. All right, number 5 for 20 goes 20 times 1, 10 times 2, 5 times 4. So the pair we're going to need is the 5 and the 4, okay? And how do we make them add to negative 9 and multiply to positive 20? Well, they're both going to have to be negative, right? So y minus 5 times y minus 4. Okay. The rest of them, factoring the trinomial when we have a GCF, all right? So number 6, what do these three terms have in common? The 4x squared, the negative 12x, and the negative 72. Well, they're all multiples of 4, right? Because 4 times 1 makes 4. 4 times negative 3 makes negative 12, and 4 times negative 18 makes the negative 72. So what I can do, we can take out that GCF. So we're going to write this as 4 times x squared. 4 times negative 3x makes the negative 12x. And then 4 times negative 18 makes that negative 72, okay? And now we can factor what's inside the parentheses. So we need a factor tree for 18. 18, 18, 1, 9, 2, and then 6 and 3, okay? So the pair that's going to work is the 6 and 3. So we're going to keep that 4. Put an x over here and x over here. And let's think about what the signs have to be to make them multiply to negative 18. So one of them is going to have to be positive, one's going to be negative, and then add to negative 3. So it's going to be negative 6 and plus 3, okay? So I'll leave you to check. When you multiply these two out, you'll get what's in the parentheses up here. All right, number 7, the GCF in 7 is a 2. So we're going to take out y squared minus y minus 30. Okay, this one's a little trickier. So let's make a factor tree for 30. 30, 30 times 1, 15 times 2, 10 times 3, 6 times 5, and then 7, 8. No, that's it. Okay. So we want them to multiply to negative 30 and add to, remember there's a negative 1 understood to be in front of that y. Okay. So we need a pair that either adds or subtracts to 1, which is going to be the 6 and the 5. All right. So that's going to, we'll keep that 2. Y and a y in the front. So let's think how we get them to multiply to negative 30. One of them has to be positive, one of them has to be negative, and add to negative 1. That's going to be a minus 6 and a positive 5. All right, last one, we have a GCF of 10. It's going to be x squared plus 10x plus 25. All right, so 25 goes 25 times 1, and then the only other way to make 25 is 5 and 5, okay? Which, that's going to add to the 10 and multiply the 25. So this is going to be 10 times x, everything's positive in here, so these signs are all going to be positive, okay? Another way to write this is 10 times x plus 5 squared, okay?